Good morning, students. Once again, welcome to physics class. In the previous class, we have discussed basic concepts of physics and also introduced physical quantity, fundamental quantities, derived quantities and their units. Now today, we are taking a topic that is system of unit. System of unit. Basically, the system in which we are measuring the quantity. Like when we are taking meter, centimeter, for that are taken as to be different units for the length. Likewise, we will use it for other physical quantities. So today we are starting with the first topic, system of units. It is a complete set of basic and derived unit. It is called a system of unit. Basically, there are three system of units. First is FPS system. FPS system, this is also taken as British Engineering System of Unit. Actually, what we have to understand here, that F, P and S, this is signifying some word. What is that? F stand for foot. That is taken as the unit of length. Pound is taken as the unit of mass, and second is taken as the unit of time. So in FPS system, for length, mass and time, these will be the unit. Similarly, we have second system, CGS system. CGS system, again, it is another system where for the unit of length, we are using centimeter. For mass, we will use unit gram. And for time, it will be same, that is second. So in CGS system, here mass, length and time are measured in gram, centimeter and second. So these are the three basic units of these three physical quantities. It is also taken as a Gaussian system. One name has been given to it. This is a Gaussian system. Now, we are taking third system, that is MKS system. MKS, M stand for meter, K for kilogram, S for second. Again, M meter for length, K kilogram for mass and S second for time. So basically here these are the units of fundamental quantities. That is fundamental quantities, that will be length, mass and time. So here we have introduced basically three system of unit. First, this is FPS, second is CGS and third is, this is your MKS. Basically FPS system, system is losing its popularity. Reason being, this is the toughest system. How? Like foot, if you are familiar with foot, that 1 foot is equal to 12 inches. 1 inch, it is difficult to convert it in the centimeter. Why? Because we have measurements, but we cannot express it in multiple or sub-multiples of 10 in FPS system. That's why this conversion is difficult. It is losing its popularity because of inconvenient multiple and sub-multiple. Whereas in CGS system, it is used, and here suppose 1 centimeter and meter, when we are related, then 1 meter is 100 centimeter and 1 centimeter is 1 by 100 meter. Similarly, there can be conversion for gram and second is the same one. Whereas MKS system, meter, kilogram, second, this is the common system which we usually take. Here we can usually make easy conversion from MKS to CGS conversions. Why? Why these two are preferable, this MKS and CGS? Because of interconversion of the terms or conversion in the factors of 10. So these CGS and MKS system are taken as metric system. Metric system, which can be expressed as multiple and submultiple of 10. Like we can take it as you can just take it as 1 meter equal to 100 centimeter. That is 10 raised to the power 2 centimeter. That is, it is multiple of 10. 10 into 10. Whereas if we are taking 1 centimeter, it is 1 by 100 meter. You can take it as 10 raised to the power minus 2 meter. 1 centimeter is 10 raised to the power minus 2 meter. So that's why when meter and centimeter, that means MKS and CGS system we are converting, these are expressed as multiple and submultiples of 10. So that's why these are called as metric system. Now FPS is losing its popularity because of inconvenient multiple and submultiples, because easily it cannot be convertible in another form, another system. So these are the three systems. Apart from these three, one is International System of Unit. This is the modification of MKS. See, as MKS stand for meter, kilogram, second, for the fundamental quantities length, mass and time. When this International System of Unit will be taken, units for mass, length and time will be same as that in MKS system. But this system which we are taking here, this system was developed by General Conference on Weights and Measures in 1971 for international uses in scientific, technical, industrial and commercial work. So you can say that if MKS and this international system, which we take it as SI system, you can term it as SI system. So if the quantities are measured in the same unit, so what is the advantage of SI system? Why we have introduced this system? Why to study this system? So let me introduce you what is the benefit of introducing of this system. What are the advantages of SI system? Now, advantages of SI system. Here, the question can be asked that give the advantages of SI system, or its advantages can be asked in definition form also. So, learn and understand this particular topic carefully. First is covariant system. C-O-H-E-R-E-N-T. Covariant system. What is the meaning of covariant system? Covariant system is a system in which all the units that are derived units that can be obtained by simply multiplying or dividing the fundamental units. It means when we are deriving a unit, that will be obtained by multiplying or dividing the fundamental units. But one important thing, without introducing numerical factor. This is a key point here. Without introducing numerical factor. Let me understand it by taking example. See, as if we are taking, suppose speed. Speed is a physical quantity having formula distance per unit time. Like now, unit for distance is meter and for time is second. So its unit will be meter per second. So when we are taking, we have simply dividing fundamental quantity, basic quantity distance with time. Is there where we have introduced any numerical factor, any multiplying factor there? No. Covariant system is a system here we can multiply or divide the units. Basically, when we are talking about units, first of all, obviously we have to take the unit from the formula. So here, when we are taking a particular formula, when the quantities are multiplied or divided, automatically their units are also multiplied or divided. So that's why we have taken covariant system is a system in which units can be obtained by multiplying or dividing fundamental units, especially without introducing any numerical factor. No numerical factor like multiplication with half or some other means can be introduced. You can take like kinetic energy is half mv square. This formula, this we have obtained by certain means. Basically, when you are taking its unit, that half is not contributing. So that's why we are saying that no numerical factor has been introduced in the units. Now after this, next advantage of SI system is rational system. Very important term. This is important term. See, covariant system can be asked directly. You define covariant system. What is covariant system? Likewise, it can also be asked, what is rational system? So, first of all, we will understand it. What is it? It uses only one unit for a given physical quantity. What does it mean? For a given quantity, only one unit is there. Like if we are taking energy as a physical quantity, and it may have different types. You can take it as heat energy, electrical energy, mechanical energy, nuclear energy. These are few I have named. Many more different branches of energy can be there. Different branches, it can be different types of energy can be there. So all these are the different forms of energy. So basic quantity here is energy only. So for all these physical quantity, only one unit will be used. In this SI system, this rational system is a main point which is distinguish it from MKS. This will give the exact difference why it is modified version of MKS system. See, as in this SI system, energy, whatever be the form, all will have the same unit, and that unit will be joule. That unit will be joule. But when we are taking it in MKS system, when you will take it for the MKS system, you will see that this mechanical energy will have its unit joule. Mechanical energy will have unit joule. Heat energy, this will have its unit calorie. Many a times you have heard. And this is electrical energy, this is kilowatt hour. You have heard about it, this kilowatt hour, commercial unit of energy. We have studied in class 9th, conversions also. So this is the main point, that in MKS system from different energy units will be different. But in SI system, being this is an SI system, only one unit will be used, that is joule for all the type of energy. So this all I have written this point in language. You can learn it from here. This example I have explained for it. Now, next point is metric system. Metric system I have introduced this before also. Metric system in which the multiple and submultiple of units can be expressed in power of 10. That means I have already said that when you are converting meter into centimeter or centimeter into meter, you are getting the conversion 10 raised to the power 2 centimeter, that is equal to 1 meter, or 1 centimeter is 10 raised to the power minus 2 meter. So multiple and submultiple of 10 is metric system. Next important point is absolute system. Absolute, this is also a point where you have to just pay attention, like rational system. Absolute system, in simple terms, if you take unit of force, in SI system, SI unit of force is Newton. Its CGS unit is dyne. This is in absolute system. This is in absolute system. Means if you will define 1 Newton, 1 dyne as force is mass into acceleration. So acceleration will be 1 unit. Means 1 meter per second square or 1 centimeter per second square. For a body of mass 1 kilogram, if we are defining 1 Newton or 1 dyne, or for a body of mass 1 gram when we are defining it for CGS. Actually this concept will be coming in detail in laws of motion, our third unit. But for the time being, I am explaining the concept of absolute system. I will simply take that in this system, here when acceleration we are taking, that is 1 meter per second square, where there is no concept of gravitational unit is introduced, means where acceleration due to gravity is 9.8 meter per second square, there we will consider the effect of gravitational unit. In gravitational system, you will take a unit where G effect, that is effect of gravity, is considered. In the junior classes, you have studied the unit of force to be 1 kilogram weight. So 1 kilogram weight is a unit that is in gravitational system, gravitational SI system. Whereas 1 gram weight is a gravitational unit in gravitational system, that is CGS unit. So here in both the cases, what is the difference? That here acceleration due to gravity will be 9.8 meter per second square, whereas in CGS system, in gravitational unit, that will be effect of gravity, that is acceleration due to gravity will be 980 meter per second square. So here when you will understand, you are understanding the concept of absolute system. In simple terms, it means in absolute system, acceleration due to gravity is unit, but in gravitational system, that acceleration due to gravity will be existing. That means either 9.8 or 980. That means 9.8 meter per second square or 980 centimeter per second square. But this is only for understanding purpose. No need to write these steps. This is for explanation part. Here you have to write this step that it does not use gravitational unit. Now the last point is it is international acceptable system of unit. Obviously, when we are discussing any kind of unit, that should be uniform, that will be internationally acceptable at all the points, all the places throughout the world. Like in India, in US, in UK, everywhere unit must be same. That's why there was a team, there was a committee that was introduced in 1971, that was General Conference on Weight and Measure. That committee decide which unit is used for which physical quantity and all these things. So let me take that what we have done in advantages: covariant system, its definition you have to learn; rational system, definition and example you have to learn; metric system, definition; absolute system, and international acceptance. So these 5 points you have to learn, because question can be asked as advantages, features, characteristics of SI system. Now after this, next, that is a basic thing we are doing, that is just for general uses of units. As here we are discussing guidelines for writing SI units in symbols. Basically, how to write the units, what is a basic rule to be followed, let me discuss them. First point is small letters are used for symbol of units. Like if we have to write meter, so meter, M-E-T-R-E, M should be small. Like for second, S, that should be small. So small letters are used for symbols of units. Then symbols are not followed by punctuation mark or full stop. What does it mean? Suppose a physical quantity is obtained by multiplying. Like if you are taking, that is force multiplied by distance. If you are getting a quantity work. So unit of force is Newton. This Newton, that is Newton, and unit of length is meter. So Newton meter. There should not be dot placed in between. No punctuation mark, no dot should be there. It should be separated by a space. This is a rule you have to follow while writing the unit. Third, the initial letter of the unit can be capital only if the unit is named after a scientist. How to understand? Like unit of force, SI unit of force is Newton. So when you have to represent it symbolically, then you will use the letter capital N. When you are using SI unit of work, energy, joule. So when you have to write symbolic representation, single letter, then capital J. Watt, unit of power, capital W. Why? Because these are named after the name of scientist. Whereas when you are writing complete unit like Newton, joule, watt, then small. The first letter should be small. That should be, if you are writing, like you will write it as, how you will write? Like Newton, symbolic it will be capital N. Watt, this is small here. This will be capital W. Even when you are using meter, then it is small m, because here it is not named after a scientist. So for units which are not named after a scientist, you will simply write by the small letter, but that are named after a scientist, symbolically you will write by a capital letter. And when the quantity is obtained by multiplying two physical quantities, their units will be separated by a space, not with a dot, punctuation mark. Next point is, full name of unit always begins with a small letter that I have mentioned, even if it is named after a scientist. This point I have written here. Whether it is named after a scientist's name, it will be starting with the small letter. Next, symbol does not take plural forms. You will not write seconds, meters, joules. Unit always come in singular. Joule, meter, whatever be the number, whatever be the amount, unit will not be in plural. Then here is a table giving you abbreviation in power of 10. So you have not to learn. Basically, when you will use multiple and submultiples of 10 here in physics while doing calculations and numerical part, automatically you will be updated about it. But you must be familiar with it. So let me just have a view of all this. This is prefix. That means, what is the meaning? Just like we are taking centimeter, decimeter, millimeter, micrometer, these terms you are familiar with up to class 10. So if deci is used, the symbolic representation will be small d and the value will be multiplied by 10 raised to the power minus 1. Similarly, centi, symbol is small c and value is 10 raised to the power minus 2. Milli, millimeter, milliampere, many a times you have used this milli, small m, and its value is 10 raised to the power minus 3. Micro, micro symbol is mu, like you write symbol as u, you write symbol u, you will slightly just take a symbol like, I am again writing, like you are writing and simply you will write like this. This is mu symbol, micro, and its value is 10 raised to the power minus 6. Nano, small n symbol, value 10 raised to the power minus 9. Pico, small p, value 10 raised to the power minus 12. Up to this, maximum values, multiples or submultiples will be up to pico. Next 3, 4 prefixes we are using. This is for your understanding. Very rarely you will use it. Femto, 10 raised to the power minus 15, small f. Atto, 10 raised to the power minus 18, small a. Zapto, 10 raised to the power minus 21, z. Yacto, 10 raised to the power minus 24, small y. So just up to pico or maximum femto. This is the main points, where especially initial ones, basically nano, pico. This is the value you have to learn or you will be familiar with when you will continuously using. Don't force yourself to learn the values. Slowly and slowly you will be learning all these values. Next is prefixes for, these were submultiples, 10 raised to the power minus. Now we are taking the values in multiples. Like multiple means 10 raised to the power positive. How? First prefix is deca. Symbol is dA, small dA, 10 raised to the power 1. Hecto, 10 raised to the power 2, symbol H. Then kilo, 10 raised to the power 3, we are familiar with, K symbol is used. Mega, 10 raised to the power 6, capital M. Giga, 10 raised to the power 9, capital G. Tera, 10 raised to the power 12, capital T. Peta, 10 raised to the power 15, capital P. So basically up to giga, that will be used. Up to giga value. Later values just you can note down. You can anyhow, whereas at rarely you will use these particular multiples of 10. So you are familiar with around from this table. That is peta, exa, jeta, iota. So these are the symbolic representations, that is E, Z, Y, and these are the values. So basic points you have to see, this is up to pico and this is up to giga. These values you can just you will use it within the calculation. Now after this table, let me discuss few practical units for measurement of distances. Here practical units for measurement of distances, first is astronomical unit. See, you have to learn these values simply for the definition point of view, and in terms of values you can learn it. Otherwise in this complete unit you will not use it. Astronomical unit, symbolically it is represented by capital A, U. It is the mean distance of Earth from the Sun. Distance between Sun and Earth, that is measured to be, one astronomical unit is 1.5 10 raised to the power 11 meter. Second is light year, symbol Ly. As the term indicates, it is the distance travelled by light in 1 year. Distance travelled by light in 1 year in vacuum. So it is given by 9.5 into 10 raised to the power 15 meter. Parsec. This slightly you have to understand. It is the largest practical unit of astronomy. Sometimes 1 mark question can be there. Which is the largest practical unit of astronomy. It is defined as the distance at which an arc of length 1 astronomical unit subtend an angle of 1 second. So to understand it, let me take as for the concept of arc, this parsec concept, if I am taking, this is an arc of length 1 astronomical unit. See, you have seen 1 astronomical unit, you cannot simply observe it, such a large 10 raised to the power 11 meter, but I am just taking a depiction of it. So if this particular arc at a distance of 1 parsec, 1 parsec is a distance at which an arc of length 1 astronomical unit subtend an angle of 1 second. Subtending an angle of 1 second, then this distance, this particular distance is 1 parsec. Just the concept of astronomy. Here we have to learn its definition and understand the concept. Now, this 1 parsec is equal to 3.1 10 raised to the power 16 meter. And 1 light year is equal to 6.3 10 raised to the power 4 astronomical unit. 1 parsec related with the light year as 3.26. So these are 3 practical units of measurement of large distances, basically all in astronomy. Next, we are taking practical units of time. Few terms you are familiar with and 2-3 new terms we will introduce here. Let me take a just review of all these terms. Solar day. It is a time taken by Earth to complete 1 rotation about its own axis with respect to Sun. You have to just simply understand, learn this definition, as it is clearly indicated that Earth to complete 1 rotation about its axis with respect to Sun. So whatever time is taken, that is solar day. Sidereal day. It is a time taken by Earth to complete 1 rotation about its axis with respect to a distant star. Sun itself is a star, but with respect to any distant star, if we have to measure the time, that is sidereal day. Solar year. It is a time taken by Earth to complete 1 revolution around the Sun in its orbit. This is basically which we are familiar. Like 1 solar year is 365.25 average solar days. or 366.25 sidereal days. You have to simply just learn it, and the basic definition. Very rarely it can be asked in the exam. Tropical air, the year in which there is total solar eclipse is called tropical air. It means there is complete solar eclipse throughout the year, that is taken as to be tropical air. Now, leap year. Year which is divided by 4 and in which month of February has 29 days. This is called leap year. This you are familiar with. Century. 100 complete year. Take 1 century. Shade. This is a new term. Small unit of time. It is the smallest practical unit of time. Smallest practical unit of time. And 1 shake is 10 raised to the power minus 8 second. Lunar month. It is a time taken by moon to complete 1 revolution around Earth in its orbit, and its value is 27.3 days. So students, these are all practical unit of time. This is general for learning purpose. Sometimes 1 mark question can be there and anyone can be asked, and this is rarely asked. So just learn the values. And now today and the previous lecture we have introduced some basic concepts of physical world and measurement. Now you have to understand the basic terms and learn the things, complete the notes. Now tomorrow onward we will take very important new topic that is related with dimensional analysis. So that is a new concept. There you have learning and understanding the things. So for today, you have to complete all this work. So take care. Have a nice day. Thank you.